In this video, we will use what we know about right triangles to think about this non-right triangle. So consider this non-right triangle here. We know the lengths of each side, and we know that one of the interior angle measures is 0.78 radians, but we don't know the measures of the other two interior angles. And that's actually what we'll find in this video. So to think about this, we're going to use what we know about right triangles. So let's split this non-right triangle into two right triangles. So we'll draw that line down there, which forms this right triangle over here on the left, and then this right triangle over here on the right. So we've got two right triangles to reason about, and that'll help us think about this. So I'll redraw this green right triangle that's on the left-hand side. So like that, we've got an angle measure of 0.78 radians. We've got the hypotenuse of this thing is 1.2 centimeters long, and we don't know the other side lengths. But we can actually determine these side lengths using right triangle trigonometry. So the vertical side length should be 1.2 times sine of 0.78. And the horizontal side length should be 1.2 times cosine of 0.78. So we could compute those values, but we'll leave them like that for now. And then we can also draw this red right-hand side right triangle. I'm going to reorient this thing and put it in standard orientation. We'll draw like that. This measure right here is alpha. We have a hypotenuse that is 1.762 centimeters long. And from the original diagram, we're actually not given any information about the horizontal side length or the vertical side length. But notice that this vertical side of this right triangle matches the vertical side of this one. Those two things are touching up here at this black line that we drew. And therefore, the vertical side length of this red right triangle is actually 1.2 times sine of 0.78. That's what we computed over here. And that value is approximately 0.844, about 0.844 centimeters. So if we know a vertical side length and a hypotenuse length for a right triangle, we could actually say that sine of alpha is equal to 0.844 divided by 1.762. So it's the vertical side length measured in hypotenuse length. And therefore, alpha is equal to sine inverse of 0.844 divided by 1.762. And that has a value of about 0.5. So we can say that alpha is about 0.5 radians. And we can actually fill that in both of our diagrams. So now we have two of the interior angle measures, and we want to know the other one. But recall that with any triangle, the interior angles add up to 180 degrees. And 180 degrees is pi radians. So if we take the radian angle measure of all of these interior angles and we add them up, we should get pi radians. And therefore, 0.78 plus 0.5 plus beta, which is our other angle measure, is equal to pi. And so this angle measure that we're missing is equal to pi minus 0.78 minus 0.5. And if we compute that value, we have a value of about 1.86 approximately. And therefore, beta, this angle measure up here, is approximately 1.86 radians. So this looks like kind of a lot of work, and it looks maybe a little sloppy, but when we split things up into right triangles, we can use a ton of our trigonometric tools to reason about the right triangles, and then put them back together in the context of our original non-right triangle.